Welcome to Spring LIB.
Now for this question, we are given that the lambda baryon uh, cannot decay via these three different decay modes. And I want to figure out why. So we're going to look at three different conservation laws systematically, right? This is usually what we do in order to determine whether a reaction can proceed or not. And that is on the right hand side over here. First, we will look at the charge to see whether the charges are the same from the left hand side to the right hand side, whether it's conserved. Then next, we look at the baryon number. They must be conserved as well. Then lastly, we can look at energy conservation. Energy conservation in this sense talks about whether this can be a spontaneous reaction, because we are looking at a decay, right? Decay reaction must be spontaneous. It means that the total energy, rest energy of the initial products must be higher than the rest energies of the final products. So let us start off with uh, the first reaction over here. We're gonna look at the charge first. So it is neutral, right? The lambda baryon is neutral. The neutron is neutral, but our pion in this case is a negative pion. Right, so you can see that the charge is not conserved because the right hand side has a charge of -1. So in this case, it is violating the conservation of charge. Next, we look at the second equation. So looking at the charge, the proton is a +1, the kaon in this case is a -1, so they balance out each other, so that's conserved. For the baryon number, the lambda baryon has a baryon number of 1, proton has a baryon number of 1, kaon is a meson, so it doesn't contribute any baryon number, so that's conserved as well. Now looking at the energy conservation, the lambda baryon has a rest energy of 1115.7 MeV. The proton has 938.3 MeV, and the kaon is 493.7 MeV. So these are the rest energies. However, if you were to add the final products together, the rest energies, we get 1432 MeV, which is greater than our rest energy of the lambda baryon. So what this tells us is that this cannot be a spontaneous reaction and decay, so it cannot occur as a decay, right? Because decay are meant to be spontaneous, right? Without any additional energy input. So in this case, it is because it violates the energy conservation. Now for the third reaction equation, first off, you look at the charge again. It is neutral, so the right hand side has a pi plus and a pi minus, so they cancel each other out, so that's fine. However, looking at the baryon number, the baryon number is 1 because this is a baryon, but both the pions are mesons, right, which contributes 0 to the baryon number, and so for this case, baryon number is not conserved, and so that is why these reactions cannot take place.